Yes, Shahid, am I audible to you? All right. See, in the last class, we had started with capacitance. So basic formulas we have to discuss. We didn't discuss it. So I hope you have revised and come.
Yes.
All right. Yes. So instead of writing everything, I'll do one thing. I'll discuss these with you directly. So you will answer, then I'll be writing. So at least you'll have all these written in your notes as well. All right. So yes, how is charge related with capacitance?
C is equal to Q by V.
C is equal to Q by V. So charge is CV, right? Charge is CV. Now see, what you have to remember, that capacitance is independent of charge and potential. It depends only upon the geometry. It's a scalar quantity and SI unit. You are already aware of capacitance. Capacitance formula is this, but SI unit of capacitance we put it as farad, 1 farad. So 1 microfarad's conversion. How do you convert 1 microfarad into 1 farad, 1 picofarad into 1 farad, 1 nanofarad into your SI units? Because ultimately you will be having farads as your SI unit. Now this is parallel. Whenever you have a graph, if I ask you to plot a graph between capacitance and charge, and I ask you to plot a graph between capacitance and voltage, what type of graphs will you obtain? We are having two kinds of graphs. First graph is between charge and potential. The second graph is between capacitance and potential. So what type of graphs will be obtained over here? Plot it in your registers, the type of graphs. See, you have two quantities over here. So we are comparing both of these. Just tell me the basic nature of the graph.
For capacity. For capacity.
For capacitor, yes, for capacitors I'm asking. See, we have two physical quantities over here, right? And now we are dividing both the quantities. One for the charge we are getting, one for potential we are getting. So you have both the quantities, one in the numerator, one in the denominator. So if you are asked to plot them, right? One graph between these two and one between these two. So what will be the nature of the graph that we'll obtain? Even if you have to draw both the physical quantities in the same graph, or you can draw them separately.
For C, capacitance and charge will be straight.
It would be a straight line. And what about potential?
Downwards hyperbola.
See, when I had started, I had clearly mentioned this fact that this quantity, this is independent of both the charge and potential. Charge and potential, this is totally independent of all these quantities. So for both the quantities, you are having a single type of graph. All right, class? You are having a same type of graph in which you will be plotting both the quantities, or you can plot it separately. But see, the nature of the graph will remain the same. Now the reason to it. See, whether it's charge over here or it's potential over here. Now look, why is the nature of the graph in this manner? Firstly, capacitance, this is independent of the charge. It does not depend on both the quantities. The reason is that when you substitute in the values of potential, if you are having a point charge, for that, what is the formula of potential? Same lesson.
V equal to V is equal to W into Q.
W into Q for a point charge. That's how you calculate. If you're just having a point charge you can take, or a sphere you can take for both of these.
AQ by R.
Exactly. Yes. This is the formula. You have to refer to this formula only. KQ by R, right? If you are having force, then you have KQ square by R square, we refer. If you're just talking about electric field, then we just eliminate one of the charges. When you're talking about potential, then you just simply have KQ by R. So if you take the equation, if you take this second equation, let's mark this as second equation. This is our first equation. Let us substitute the value in here. So what is the value that we'll obtain? This
R by
is
K.
K, exactly. This is 1 by K. So 1 over 4 pi epsilon naught. Now look, 4 itself, it's a constant number. Pi itself is a constant number. Epsilon naught, this is also a constant number. Just give me a second. Just a second. Yes, see, right. So here we have, this is a constant number. Pi, the value of this is also 3.14. So this will also be a constant number. When we are talking about epsilon naught, so this is permittivity in free space. So we already have a constant fixed value for that. 8.85 into 10 to the power minus 12. You already have this fixed value. So that's why we are saying we eliminate both the numerator and denominator. Understood? That's why neither the numerator stays or the denominator. That's why we are saying both the graphs are same. So you can plot both the quantities in the same graph. All right, then we have the normal formula for parallel plate capacitors. We have certain cases for them. First, tell me if both of these plates, I have taken both of these plates. One plate is positively charged, the other plate is negatively charged. If air is the medium between them, what is the formula of capacitance?
A epsilon naught.
Epsilon naught A by D, right? This is the formula, epsilon naught A by D. Okay, if a dielectric slab is introduced over here instead of this air, then
AK epsilon naught by D.
K epsilon naught A by D. Very good. These two are at least you thought with. Now, before we move on to some other question, some other formula, I want a very important question is there, which I want to discuss with you. Do one thing just before that, no, just note down these few points. Yes, Shahid, start noting down it from here. Then a very important question, and it's a difficult question also I want to discuss with you, but first note it down. Shahid, have you written the question?
Yes, ma'am.
Did you try any answers?
I'm trying.
Do you need 2 more minutes?
Yeah.
Okay, fine. Then after 2 minutes, I'll discuss it. See, one hint, let me give you one hint. So that by chance, if you are doing incorrectly, you get a hint. Just take a very narrow section from here, very small section, and then calculate DC. We calculate, no, C is equal to epsilon naught A by D. Take a very small section, so this becomes epsilon naught dA over Y. That is the separation between the plates, right? This is Y naught. Y, I'm taking the overall as Y, because Y is not just Y. This is actually the sum of both the quantity. This is Y naught plus your C. One more thing that I haven't written that will be helpful for you. This is Y naught and this is Y1. That also you can use. Now apply this and use integration. Then try. Because otherwise, if you will try with the normal formula, you will not get the solution. And you cannot even resolve the resolution of vectors also cannot be done. Entire your y, this is made up of this plus this quantity. One more thing, Shai, that will help you is that use the equation y is equal to mx plus c. Because this is acting as a slope, you are having y-intercept also, right? Calculate using d tan theta. Y gives you the distance between the capacities, all right? At this,
You
along
should
this axis.
integration also.
Yes, integration you have to perform. See how you have to perform integration is from 0 to L. Take this as 0, lower limit, and the final limit will be L. See, if you calculate this part is y1, right? This part is y1. Assume this to be something. This is x. So what will tan theta become? Tan theta will become y1 divided by x. From here, you have the value of y1 as x tan theta. right? Now your entire y, no, this entire y. When we are talking about y, what is the total separation that we need? See, we are just taking a very small area, dA. How will you calculate dA also? That is also one thing. How will you calculate dA? See, if the length of this breadth is b, we know. And let us assume that this very small portion is dx, because you have to assume this also as something. So what will be the area? If this is breadth b, this is small, very small portion, this is dx. What will be the area? You tell me, Shahid.
B dx.
B into dx, very good. So at least now you know your dA is solved. dA is b dx, because this will help in your integration. No, from 0 to L, when you will integrate, you should have distance, then only you will be able to integrate, right? Now we are taking one separation. This is b, we have taken. Now one in the separation between the plates, the entire separation between the plates, that we have assumed to be y. Now your total separation, the total separation that we are having, this is, forget this y naught right now, this y naught plus this y1, right? So total what you are having, y will become y naught, this y naught plus the y1. Now what do you have as the value of y1? Substitute in here. Y will be equal to y naught plus x tan theta, right? This is one equation. So you have the value of y over here. You have y, you have dA. Now substituted. So what is your value of capacitance? DC. DC will be epsilon naught. Instead of dA, I will write b dx. Instead of y, I will write y naught plus x tan theta. And for finding out the capacitance, this will be integrated from 0 to capital C. This will be integrated from 0 to L. This is the equation which you have to solve, and your answer will be obtained. How will you solve it? This is your simple method.
Epsilon naught, we should take it outside.
Huh?
We should take the epsilon naught outside.
Epsilon naught and B, both the things.
Yeah.
B will be also outside. So see, just tell me one thing. If I'm having dx over y plus x tan theta, I'm integrating it from 0 to L. Right? This is the case. You agree? Just tell me, is it looking like something which you can solve further? Dx over x. Integration of dx over x.
We can bring the denominator to the numerator and write -1.
See. Why do you need to do that? You're getting a standard equation. It's just that you're not able to identify. Integration of dx over x is what? Integration. See, I am asking you this. Integration of dx over x. What is this? How do you write this? Forgotten the rules of integration? Log. Yes or no?
Yes, ma'am.
Log, no. Whenever you have integration of dx over x like this, so this becomes log of x. And similarly, whenever you have log of x, then it becomes 1 over x. These are the two inverse operations, no, that we use. So this is how you can further solve these questions. Till this step you have obtained, but still your answer is not definite here. Or one more thing you can do. Do one thing. Take out tan theta also here. So now what you are left with? Log is there. Y naught, this will come in the denominator. No, this is y naught, sorry. This will come in the numerator. This was log. So this is y naught plus x tan theta. Now you can integrate it from 0 to L. It's just that I have taken tan theta common. So if tan theta has been taken common, I have to put tan theta over here, right? This is the case that we have taken. So as to shift it above also. This you can solve. This also you can solve further.
Yes.
What is the next step? What should be the next step according to you? Tell me, I'll help you. The entire thing I'll solve by myself, but I want you to at least think once.
Should I substitute L?
Yes, very good. We'll substitute the value of L. This was from 0 to C integral. Whenever you have no integral of DC, integral of dW, that becomes C only. That becomes work done only, like this. Because there are many questions where you encounter such. Now, what are we left with? Epsilon naught B divided by tan theta, and we'll substitute the values of L. So see, this is log, this becomes y naught plus L tan theta first minus L y naught minus, this is this entire term, this becomes 0.
Yeah.
So yes, this becomes 0. Now we just have to solve this further. See, this will vanish. So this becomes epsilon naught B divided by tan theta y naught plus L tan theta divided by y. This we are having. Now see tan theta's value also, you know, that is y naught by L. No need to write x or this time. No, you know the complete length is L. So tan theta is y naught by L. Now substitute the value. So this becomes C is equal to epsilon naught B. This becomes tan theta is y naught by L. Here also ln you have y naught plus, this becomes L into y naught by L, right? Tan theta divided by y naught. So L will get cancelled from here. So what are we left with? This becomes 2y naught. So epsilon naught BL divided by y naught ln 2y naught by y naught. So y naught will also get cancelled. Log 2 you are having. So final answer will become capacitance will be epsilon naught BL log 2 by y naught. This is the final answer. Clear?
Yes, sir.
Okay. Note down the solution. Note down each step. See, Shahid, the spheres that are connected, no, this is the initial condition of the spheres. They are then connected. Then you have to find out the ratio of these charges, Q1 and Q2. Q1 prime and Q2 prime, these are the initial charges. Just note it down, give it a try, then I'll discuss it. Yes, Shahid, your answer. Okay, tell me one. Did you try? Did you try the question?
Yeah, I'm trying.
Any answers by now? Actually, tell me one thing. After connecting, which quantity will be the same? After connecting, tell me one thing. Which quantity will be the same? No idea. Yes, no, what? Shahid, am I
Capacitance
audible?
and capacitance.
Capacitance will be the same. Why?
Uh,
Potential will be the same. See, whenever you connect two spheres or two quantities, no, 2 point charges or two spheres, it's the charges that travel from one body to another till the time their potential becomes same. Suppose Q1 is higher, or let's say Q2 is higher, whichever charge was higher initially. Now what happens is that once you have connected them, the charges will flow till the time both the potentials are same. All right, till the time
yes,
both the potentials are same. So V1 is equal to V2. So for this, I can write it as K Q1 by R1. This I can write it as K Q2 by R2. So K will get cancelled from here. Firstly, ratio of Q1 by Q2. This will become R1 by R2. This is your answer in one line. This is a very easy question. Now, what all modifications can be asked in this question? It can ask you to calculate ratio of surface charge densities. So, sigma 1, this is equal to Q by 4 pi R1 square. Sigma 2 will be equal to Q by 4 pi R2 square, right? So Q, no, this will be Q1 and Q2, no, so they won't be cancelled. So this becomes Q1, this is Q2. So 4 pi, this is 4 pi. Now what are we left with? This becomes Q1 R2 square divided by Q2 R1 square. What is the value of Q1 by Q2? From here it is R1 by
R1 by R2.
Yes. So once you put in the value, this is R1, R2 square by R2, R1 square. So R2 this square, R1 this square will get cancelled, sigma by sigma 2. So sigma 1 by sigma 2 will be equal to R2 by R1.
R1.
All right. So
Yes.
these questions will have a very similar basic step. The earlier question which we did, no, that was a very difficult, lengthy question. But these are very simple. Suppose it asks you calculate electric field also. Calculate ratios of electric field. The ratios of electric field. E1 by E2. So electric field we have studied it as sigma by epsilon naught, right? So this becomes sigma 1 and this becomes sigma 2. Now you have the values of sigma 1 by sigma 2. So again, E1 by E2, this is equal to R1 by, R2 by R1.
R2 by R1.
Yes, R2 by R1. Clear? You will handle these types of questions, whatever is asked.
Yes, ma'am.
Note down this. Shahid, done?
Yes, ma'am.
Fine, Shahid. So that completes with capacitance also. Rest of the portions regarding those other formula, those are exactly the same in your JEE syllabus, which we have done it in our class, regular class, CBSE classroom. All right. So please revise those questions from there. Those we haven't seen, the formula based questions were there. D minus epsilon naught C, C is equal to epsilon naught A by D minus T and all, whenever conductor is placed and all. So those are exactly the same. These is especially the question above this one which we did, that is very important, because this type of question, this has come, I think, in AI EEE or somewhere. This question is there. So practice that also. Now current electricity will move on. Now in your regular batch also, we'll be starting with 5th lesson. So those lessons which are left now in your main batch class, that CBSE class 12 batch, there we are just left with small lessons from your first book: EM waves, AC, EMI, chapter 5th, that is magnetism and matter. So these are very small lessons. So for that, in that batch, no, those lessons will be completed faster. So now we have to also complete lots of questions from current electricity, because some good questions are there which I want to discuss with you. Certain circuits, some circuits I'll not do, which will involve use of inductors. Together I'll do all the circuits when AC is done.
Okay.
All of inductors you must have heard of.
What's that?
See, the way you have a device, no, capacitor for storing charges. Similarly, you have a device as resistor in your current electricity. So these two you have already studied. In AC